This is the SHM free body force diagram pendulum 8-mark question. It is the Juno 5 question 6. So it says a simple pendulum of length L consists of a small mass M attached to the end of a thread. The other end is fixed. The mass is slightly displaced through an angle of 4.0 degrees, so there's your small oscillation, and then released so that it oscillates along a small arc with center O. So here's O. Here's my string length L, here's my mass M, and it's swinging through an angle of 4 degrees. The free body force diagram for the oscillating mass at its maximum displacement is drawn alongside. So here's where we are in terms of forces when we're out here. Add to the free body force diagram the component of the weight that is equal in magnitude to the tension at this instant. Well, that's going to be a line that follows the same direction, the same line, but the opposite direction, I suppose, of the tension down here. I can't draw on this diagram, as you'll be aware, having done the question yourself. So it should be along the tension line, pointing in this direction, and it should be the same length as the tension. So those two things are important. The direction, three things I suppose, along that same line as the tension, in the opposite direction as the tension, and the same length. Then it says, add to the same diagram the component of the weight that acts perpendicularly to the line of action of the tension. Well, you're going to have a component of the weight out here, and it's perpendicular, so it has to be a right angle between the tension and the arrow you draw. That's going to be labelled B. That's going to be labelled A. Determine the magnitude of the instantaneous acceleration. Well, here, of course, we're going to have to work out the component of the weight. And that is going to be equal to ma. So we're going to say B equals mg, here we go, B equals mg sine 4 degrees, and that by Newton's second law equals ma, so my m's will cancel. So I'll end up with A equals g sine 4 degrees, which gives me A to be 0.68 meters per second squared. And state the direction. Well, the direction of the acceleration will be tangential to the arc towards O. Final part of the question then, part B. The period of the pendulum is 4.2 seconds. When the length L is shortened by 1 meter, the period is 3.7 seconds. Show how this data can be used to determine a value for the acceleration of freefall. You should obtain an approximate equation and substitute the data, but you're not expected to perform the final calculation. So we have two periods, we have a difference in lengths, and we want to work out G. So it seems sensible to start thinking about the period, because the period expression includes the length. And if we square that out as we did in the previous question, then we say, well, we've got two periods. So the difference in the periods, difference in the square of the distance of the periods is t2 squared minus t1 squared. So then, if we stick the numbers in there, then the algebra in there, 4 pi squared over g, just sticking in the values L2, L1, and then taking the 4 pi squared over g out as a common factor, we end up with that. So that gives us an expression for G, which looks like that. If we rearrange this equation to make G the subject, then we've got to stick our numbers in now, haven't we? So if we stick in our 4.2 or 3.7, and of course the difference in the length, L2 minus L1, is 1, we're told by the question. And there we have it. The substitution is done. We don't have to do the calculation. That's the solution.